everybody, welcome back. The last video kind of cut out in the middle of a problem, so I'm really sorry about that, but we're going to continue exactly where we left off from here. So where we left off at the end of part 1 was that I was about to solve our equation so that we could solve for the rate of the boat. So we are right here, 7b squared minus 40b minus 63 equals 0, and it actually factors really nicely. Let me show you. So 7b times b equals 7b squared. Positive 9 times negative 7 equals 63. And negative 49b plus 9b equals negative 40b. So it actually factors kind of nicely. But if you didn't see the factoring, that's okay. You can use the quadratic formula and we're going to get exactly the same answers. Okay? So from here, we set each factor equal to 0 and solve. So 7b plus 9 equals 0, which means that b would be negative 9 cents. If b minus 10 equals 0, I would add 7 to both sides and b would be 7. And then it is a word problem, so we need to make that our answers actually make sense. So the negative 9 sevenths, does that make sense? No, because it's negative, and so that would mean that our boat was going backwards, and he wouldn't actually go really anywhere that we wanted him to. He would go the opposite direction. And so we don't want that. We want him to be going forwards and actually go up the river and actually come back. So that one doesn't make sense in the context of our problem. The positive 7 down here, that makes sense, okay? That would be him going forwards. He would go upriver. He would come back. He's also rowing faster than the current. The current's going 3 miles per hour. And he's rowing 7 miles per hour. So that one makes sense. Okay? So we only have one answer in that one, and it's 7 miles per hour. Okay? Let's keep going. Okay. Next up are work problems. And you guys might remember these from beginning algebra if you took beginning algebra. If not, it won't take long to catch up to speed, okay? So work problems, basically work equals your rate times time again, okay? So let's start with an easier problem and then we'll move on to a more difficult one. The first one, Gina can cut the grass in a large field in 4 hours. Sarah takes 5 hours to do the same job. How long would it take them to cut grass together? So they're going to help each other out. So it should take less time than either one of them put together. Okay? So if it makes your brain feel a little better, if there were 2 Ginas, you would take half of 4, that'd be 2 hours. If there were 2 Sarahs, you would take half of 5, that'd be 2.5 hours. So with Gina and Sarah working together, we're looking at somewhere between 2 and 2.5 hours as our answer. Okay? So let's set that up. So the amount of work that Gina does will be rate times time. So her rate is she can cut the whole thing in 4 hours, which means in 1 hour she's cutting 1/4 of the field. So her rate is 1/4, and I'm just going to use a T for time. Sarah takes 5 hours to do the same job, so it takes 5 hours for her to cut grass for the whole field. So her rate would be 1/5, because she would cut 1/5 of the whole field each hour, times time. And then they're going to work together, so Gina's work plus Sarah's work equals 1 job or 1 field. Okay, so they're cutting only 1 field. If they were cutting more than 1 field, you would equal it to a different number than 1. But they're just cutting 1 field together. So that's what the general setup looks like, okay? To solve it, we'll multiply by our least common denominator again. With 4 and 5, our LCD would be 20. So I will multiply both sides by 20. 20 times 1/4 is 5. And 20 times 1/5 is 4. So now I have 5t plus 4t. On the right side, 1 times 20 is 20. Then I'm solving for t. I can combine like terms on the left side. 5t plus 4t would be 9t. So now I have 9t equals 20. And last but not least, to solve for t, I would divide both sides by 9. So t would be 20 over 9. And of course, if somebody said, how long is that job going to take? And you say 20/9 of an hour, they would look at you a little silly. So let's at least get it into a mixed number so we can see a little bit more what that is, okay? So 9 goes into 20 2 times. 2 times 9 is 18, so we would also have a remainder of 2. Nice. So our answer would be 2 2/9 of an hour, so that would be the exact answer. If you were talking to somebody, I would think about 2/9. Like 3/9 would be a third of an hour, which would be 20 minutes. If that makes sense. So this is a little bit under 3:20, so it's probably around that 3:15, between 2 hours and 15 minutes and 2 hours and 20 minutes, somewhere in that time frame if you're talking to a person. Okay? Let's move on to a slightly more difficult one. 2 chefs are preparing a banquet. One chef could prepare the banquet in 2 hours less time than the other. Together, they complete the job in 5 hours. Well, how long would it take the faster chef working alone? So this one, we're doing a work problem again. We're doing rate times time for each one. Let's see. So for the first job, or for the first one, first chef, he can prepare the banquet in 2 hours less time than the other. So his rate for that first chef, his rate would be the second chef minus 2 hours. And it would be 1 over that time that it takes. Okay? And the second chef's rate would just be 1 over x. Okay? So one chef just takes x amount of time, the other chef takes 2 hours less than that, so it'd be x minus 2. So that's what our rates look like. Together they complete the job in 5 hours. So we actually know what t is, so time is 5 hours. And they're preparing one banquet, so we'll equal it to 1 just like we did in the last one that we did. And how long would it take the faster chef working alone? So the slower chef would be x. Our faster chef would be x minus 2. You guys ready? Let's do it. So the setup for this one, for the first chef, we'll do rate times time. So we're going to do 1 over x minus 2, his rate, times time, which is 5 hours. They're working together, so we are adding our works together. The second chef's rate is 1 over x, and the time is 5 hours, equals 1 because they are doing one banquet together. And then we're going to find x, and we're going to find x minus 2. To solve for x, I'm going to multiply by my least common denominator, which would be x minus 2 times x. So I'm going to multiply every single term by x and x minus 2 on both sides of my equation. My first term, the x minus 2's divide out, so I'm just left with an x, times 1 times 5, which would be 5x. Still have an addition sign here. In my second term, the x's are going to divide out, so I'm going to have x minus 2 times 1, which is x minus 2, times 5, which would be 5x minus 10. On the right side, I have 1 times x minus 2, which would be x squared minus 2x. I can tell right now I have another quadratic equation because I have an x squared. So let's go ahead and get everything onto one side so that we can solve it from there. So first off, I have a 5x and a 5x, which would be 10x, right? So I have 10x minus 10 equals x squared minus 2x. To get everything on one side, To get it in standard form, I'm going to subtract 10 extra sides, and I'm going to add 10 to both sides. So now I have 0 equals x squared. The minus 2x minus 10x would be negative 12x, and then nothing plus 10 would be positive 10. Okay. It doesn't factor. If you think about factors of 10, 10 and 1 would give you a middle term of an 11. 5 and 2 would give you a middle term of 7. So you're really not factoring on this one. Let's look at the quadratic formula instead. So for our quadratic formula, a is 1, b is negative 12, c is 10. So we'll have x equals the opposite of b. The opposite of negative 12 is positive 12. Plus or minus the square root. B squared, so 12 squared, is 144. Minus 4ac, so 4 times 1 is 4. Times 10 would be 40. All over 2a, 2 times 1 is 2. Inside the square root, 144 minus 40 would be 104. So now I have 12 plus or minus the square root of 104 all over 2. 104 simplifies a little. So if we break that down, 104 is 26 times 4. 4 is 2 and 2. And 26 is 2 times 13. So we can take a pair of 2's out, so that's nice. So I'll have x equals 12 plus or minus 2 square root of 26 all over 2. And we can divide by 2. 12 divided by 2 is 6. 2 divided by 2 is 1, so we'll have plus or minus the square root of 26 for our answer. Now, thinking about, am I going to have 2 answers or just 1 answer? If you add the square root of 26, what am I thinking? We're going to get a positive answer. If I do 6 minus the square root of 6, then it'll be okay. But then when you subtract 2 again, it doesn't work out so well. So we're actually only going to get 1 answer for this one. We're going to have 6 plus the square root of 26 for the time for the second chef. So this is the slower one. But it asks for how long it's going to take the faster chef working alone. So the faster chef was x minus 2. So if I take this x value and just subtract 2 from it, I'm only going to subtract it from the rational number. 6 minus 2 would be 4. So the faster chef, the exact amount is 4 plus the square root of 26. And that's time in hours. Okay, if you want an approximate for that, you're welcome to type it in your calculator. So for plus the square root of 26, it's approximately at 9.1 hours to do the entire banquet by himself. Okay? And we'll keep going in part 3 with example 4. Sorry that we're being a little slower, but hopefully this is helping you all.